AC generator. Do you know that most of our electrical energy comes due to the spinning of rotors in the AC generator of power stations like nuclear power stations, thermal power stations, and hydroelectric power stations, and so on? What is an AC generator? An AC generator is a device which converts mechanical energy into electrical energy. AC generator was originally designed by Nikola Tesla. What is within? Listed here are the contents of this module. The working of an AC generator is based on electromagnetic induction. That is, whenever the flux passing through a circuit changes, an EMF is induced in it and a current begins to flow. The direction of induced EMF is given by Fleming's right-hand rule or Lenz's law. Fleming's right-hand rule. Stretch the forefinger, the middle finger, and the thumb of the right hand, such that they are mutually perpendicular to each other. If forefinger indicates the direction of the magnetic field, thumb indicates the direction of motion of the conductor, then the middle finger indicates the direction of the induced current in the conductor. Lenz's law. It states that the direction of induced current is such as to oppose the very cause producing it. Components of an AC generator. An AC generator consists of a magnet with concave cylindrical poles, an armature, and a current collecting arrangement. The current collecting arrangement consists of slip rings and brushes. Armature is a soft iron core on which a coil having a large number of turns of insulated copper wire is wound. Magnetic poles are concave and cylindrical. The concave poles produce a radial magnetic field. Slip rings. The ends of the armature are connected to two slip rings. They rotate along with the coil. The slip rings are made of metal and are insulated from each other. Brushes. There are two brushes, B1 and B2, made of carbon. One end of each brush is in contact with the rotating slip rings and the other end is connected to an external circuit. Here the brushes are connected to a galvanometer. Observe that the brushes do not rotate with the coil. Working. As the armature rotates about an axis perpendicular to the magnetic field, it keeps on changing its relative orientation with respect to the field. Thus, the flux keeps on changing continuously with time. This change in magnetic flux induces an EMF. If the outer terminals of the armature are connected to an external circuit, an electric current flows through it. The deflection of the galvanometer needle indicates that an EMF is induced. Graphical representation. Observe the plot and the movement of the coil to understand the sinusoidal nature of the induced EMF. Time to explore. Explore and learn the workings of an AC generator. Play around with the frequency and the direction. Observe the deflection of the galvanometer needle and the change in the nature of the graph. This will help you understand the workings of an AC generator. Assessment. Here is an exercise to assess your comprehension. The questions will appear one at a time on the screen. To keep your score valid, refrain as far as possible from wild guessing.